Greetings everyone. Welcome to my YouTube channel. I believe you are all well. Ladies and gentlemen, tonight I want to take you through part 2 for the introduction to Python programming. I already created a video for part 1 where we went through what is Python, how to install Python using the navigator, Anaconda navigator, how to use what you call the print statements, how to introduction to variables in terms of its assignment, the data types, which we have covered already, the strings, the integers, and the float, data structures, how to use the list, dictionary, tuples, and how to use the input function, and also how to use the function behind the list, such as calculating the length, appending an element into a list, removing an element into a list, using the pop function to remove the element in the list by its position or indexes, and also how to insert an element by the ith positions, how to concatenate lists, and also how to list them. Already this slicing, I've done a video, which if this is your first time, ladies and gentlemen, watching my video, there is a link that I've shared below for part 1. Kindly go through it, and don't forget to like, subscribe, and hit the bell button for future video notification. Right, without further ado, ladies and gentlemen, let's move on to part 2. Right, what is it that we need to cover in part 2? In part 2, ladies and gentlemen, we'll focus more on what we call the operations. And under operation, then we'll also talk about the conditional statements. And under conditional statement, we'll talk about the functions and also how to use what you call the range function. This is what we need to cover in part 2. All right, ladies and gentlemen, I will start with the operation. We have roughly 4 types of operations. The first one is what we call the arithmetic operation. And the second one is what we call the comparison operators. And the third one is what you call the assignment operators. And the last one under operators is what you call the logical operators. Let's start with what you call the arithmetic operation. Right, in Python recognizes the following types of arithmetic operation. Under arithmetic operation, we have an operation for addition, we have an operation for subtraction, we have an operation for multiplication, for operation for a power, operation for a division, operation for integer division, and also the operation for a modulus or a remainder. All right, let me just do an example. So this in terms of Python recognizes the following arithmetic operation. For example, let's say we have, maybe I wanted to add 2 numbers. Like if I say 5 plus 2, then let's do the running. This will give us 7. So this is an addition. This has to do with addition. So it means this is the sign for addition. But if I want to do subtraction, so I'll just use the minus. So with the minus, if I say 5 minus 2, then that is the operation for subtraction in Python. Then again, we have multiplication. Right, the sign for multiplication is this asterisk here. So it means if I wanted to multiply 2 numbers, I'm going to use this. This is a symbol for multiplication, which is give us 10. And then again, in terms of exponents, for example, if I wanted to work this, if I wanted to say what is 5 to the exponent of 2, which is the same as 5 times 5, which will be 25. Right? In terms of Python uses this symbol. This double symbol is a symbol for power, for a for an exponent. This is a symbol for an exponent, but if you're just using single asterisk, then this is a multiplication. You're actually multiplying. But if you use double of them, then this represents a power or an exponent. For example, here in Python, if we say we have, let's say, double 2, and this will give us 25, which says that we are now multiplying. It's an exponent. I mean, we're now, it's 5 raised to the power of 2. So this 5 raised to the power of 2, but if I just use 1, then it will be multiplication. This will be just 10. So it's very important to be able to understand this. And again, we have what you call the divisor. We know in like the symbol for division in reality is this one. This is the symbol for division, but in Python, this is the symbol for a division. So if you use this symbol to make to divide numbers, that will be the symbol for division. So it means if we say 5 divided by 2, this is the symbol. So this will give us 2.5. But how about if we say we use double lines? This is to do with the integer division. This is to do with the integer division. So if we use a single line, it means this is a true division. But if you use double lines, it's an integer division. So what it does, it divides the numbers, but it only produces an integer value. It only produces an integer value. For example, if we say 5 double lines divided by 2, this will just give us an integer. It will just say the answer is 2. It will just give us an integer, not actually a decimal, but it will just give us an integer. Because we know that it shows that 2 into 5 goes 2 times. But if we say, for example, 5 divided by 3, then for an integer, so it will just give us 1. It shows that 3 into 5 goes once. So it means when we use a double vertical lines, this is an integer. It will display an integer value. But if we are just saying 5 divided by 3, it means it will give the actual value when we are dividing. So this is so it will be 1.66666. and so on. So this one is the issue of dividing. Then again, we have what you call a modulus operator or a remainder operator. It means this one only gives the remainder when you are dividing. For example, if we say 5 mod, which is called a modulus, 5 mod mod 3, then this will only print out the remainder. It will print out the remainder to say 3 into 5 goes once, and the remainder becomes 2. And the remainder becomes 2. But how about if we say 5 divided by 2, then the remainder should be 1. The remainder should be 1. But if I say 8 mod 2, then this one, the remainder should be 0. Because this one only produces the remainder. It only produces the remainder. I believe you are following. So the plus is for addition, minus for subtraction. 1 asterisk, this one is for multiplication, but double of them, this one is for exponent. Then single vertical line, this one is for a true division. Then this one only prints out the integer division. And again, this one only print out the remainder. So this is called the arithmetic operators. These are very important in Python. One must be able to know how to actually use them. So when you are adding, we're just using plus, subtract, minus. So these are things that you need to know when you are using Python. Now we can move on to the next operators. Right, in the next operators, we have what you call the comparison operators. It means in terms of comparison operators, this has to do with, it's just a way to test whether things are true or false. So it means in under comparison operators, it's either it will display a true or a false. So it means it's dealing with what we call a Boolean. I think we spoke about this. It will either give true or false. For example, if I say I wanted to check if the following values are actually equal. So it means if I'm using the comparison operator, the comparison operator should actually print the following. So for example, if I wanted to use an equivalent sign, let's say, for example, I say A equals to 5, it means this is just an assignment. But if I say, for example, B equals to 3, and if I say it's A equals to B, I wanted to test if A and B are equal. Obviously, if I print this, then it must give us that the answer is false. Why? Because 5 and 3 are not equal. 5 and 3 are not equal. So this has to do with the comparison operator. So the double equal sign, this has to do with comparing. We are comparing actually. So we're using this if you want to check if two things are equal or not. It will print it true or false. For example, if I say we still have this symbol, if you say this is the same as not equals to. So this is the same as not equals to. For example, if I say in here, and I say instead of using two equal sign, and I was just saying not equals to. So I wanted to check. It will say the answer is true because 5 and 3 are not equal. So I'm just checking whether 5 equals to 3. So this is the signs for the comparison. But if I want to check for less than, if I say it's A less than B, already it will say false because A is not less than B. A is greater than B. But if I say it's A greater than B, it will say true, it is greater than B. But what if I say it's A is greater or equals to B? Then the answer, it will be true because it just said the A is greater or can be equals to 3. So this also would give us true. But now how about if I say it's A less or equals to, it will say false because A is not less than B because 5 is bigger than 3. So this is called the comparison operators. It's very important, ladies and gentlemen, to be able to understand how to use this. For example, if I say, if I take A and, okay, is this an example? If A plus B is this greater than 0, is this an example? Obvious, it will say, yes, it's true, it's greater than 0 because 5 plus 3 is 8, and 8 is bigger than 0. So it will give me a Boolean to say, this is true. But if I say, let's say I'm adding another value, let's say C equals to 10, then I say, is A plus B equals to C? Then it will say false because A plus B is not equal to C. But now, okay, it says C is not defined. So let's now define C. You see, it says false. Why? Why is it saying false? Is because if we were to check here, we'll see that we know that A plus B, A is 5, B is 3, A plus 5 is 8, and there is 10. You see that A and 10 are not equal. So that's why it says it's false. So this has to do with comparison operators. So it's very important to be able to know the comparison operators. So the greater than, the less than, the less or equals to, these are called comparison operators. And then again, we have something called the assignment operators. Like what I've done, I've said, okay, A equals to 5. So it means now, I think I've explained yesterday that this 5 is being assigned into the variable called A. So this is called the assignment operators. It's an assignment operator. It means a 5 is being stored inside a variable called a. So it's very important to be able to know this. This is called an assignment operators. But now let's say maybe we have the following. Let's say we are given the following. Let's say we know that, okay, x equals to 5. And now if we say x equals to 5, then again I say x equals to x plus 1 plus 1. So I want to add now. So x plus, let's say x plus 2. Then I say, what is print the x? Print the x. You see what I've done? I said, okay, fine. According to this one, we said we store, like the first one is an assignment operator, where we said we store 5 inside a variable called x. But now again, the x is being added again by 2. It means we need to increase this x by 2. Obviously, if we make a print here, the answer should be 7. So it means if we do this, it means we're going to say, let's print the x here. Then it says the x is 7. Why is it 7? It means now we are incrementing. We're increasing the value of x by 2. We're increasing the value of x by 2. Now, to avoid doing this thing of saying x equals to x plus 2, there is another way where we can use. So this sign here, when we say plus equals to, this is the same as when we say, let's say if we say x is plus or equals to 3, we are saying this is the same as saying x equals to x plus 3. So this is this symbol. So it's a plus equals to 3, which means you take the x, you increment the x by 3. But if you see a minus equals to, this is the same as you are decreasing the value of x by a certain value. So for example, if you say x times equals to, so it means you are multiplying the value of x by a certain value. So let's say here it's 3 also. It means you subtract it by 3. Here you multiply by 3. For example, let's say now instead of just doing that, we have the following. I want to copy this code again and do this. Okay, let's copy this again. So instead of writing x equals to x plus 2, I'll just write put the 2 this side, and here I write a plus here. So by so doing, it means it's the same as when we say this x should be increased by 2. So let's do the printing. If we do the printing, it must tell us that the value of x is still 7. But if I do this, let's say I want to, like, instead of adding, I want to subtract it. So let me start with the first one, where we said x is 5, but x is minus 2. Now I'm subtracting. It means now I want to reduce the value of x by 2. Then obviously the value should be 3. But how about if I don't want to do this? Instead of doing that, I'll just put a minus here to say I still want the same, but now I want it to subtract. So it's still the same function, ladies and gentlemen. Then again, okay, let me just try to do this. Okay, I was just increasing the code so that you can be able to see what I'm actually doing here. Okay, so I believe you can see it. Then in terms of the subtraction, yeah, we just do the same. So these are called the assignment operator. But how about if I want to multiply? It's just an example. Let's say we're dealing with multiplication now. I want to say, okay, fine, equals to x times 5. X times 5. So what will be the result? The result, it means you are now saying if x is 5, now take this 5 and multiply by 5. This will give us 25. But now how about we do this? Instead of putting, we put the times here and try to print again. Okay, now I've used 2. Let's use 5 again to check if the answer is the same. You see, it's now saying if x is 5, now multiply the x by 5 again. So this will give us 25. But if I put here, it means you take the 5, you multiply by 2, this will give us 10. It's very important. But now, how about if I want to check a power? Does the power works? If I put the double asterisk, then it still work with the power. It also work with the power. It also work with the exponential. So it also work with the power. So it means if I want to do this, I can just say x equals to x to the power of 2. The answer will still be the same. The answer will still give us 25. So these are called the assignment operators. I think I forgot to add one here. So let me add the other one. The times equals to. So this one it's an exponential assignment. This is to do with an exponential assignment. So it's very important in Python to be able to work out this, especially when you are doing calculation. You need to be able to know how to use the operators. And then the last one under operators, ladies and gentlemen, is the issue of the logical operators. The logical operators, which we have the AND operators and OR operators. This actually applies to, like, it also the other type of operation where it can give us either something is true or false. Obvious, if you're using AND, it means it must satisfy both the condition. So it means we focus on both. But if you're using OR, it means either of the one. As long as one of it exists, then it will take it through. For example, let's say we do this. This is just an example. I wanted to use the AND operator. So let's use an AND operator. If I say to you, I say, okay, A equals to 5, then B equals to 10, then I say to you, let's say it's A greater than 3 and B greater than 5. So I'm saying AND. So it means when I'm using AND, it means the condition will hold true if both of the two are all true. So if one of them it's not true, then it means it will not say it's true. It will just say it's false. For example, here, if we check, we know that 5 is bigger than 3, and also we know that B should be bigger than 5. So let's do the running. Then it says an exceptional indent. Okay, fine. So it says it's true. Why is it true? It's because it satisfies both of these. But if I say to you, okay, fine, let's say if we say, I want to say it's A equals to 3 and B bigger than 0. It will say 5. You know why? Because an AND should satisfy both the condition. It's like, since 5 is not equals to 3, even though B is bigger than 5, then it will say it's false because it's not satisfying both of the condition. And this is one of the things that we usually use in Python. For example, when we are dealing with the if statement and the others. Right, again, how about if I do this? You find that, like, if I want to use the word AND, what if I do this? Just want to show you something. Let's say I put something like this and let's run it. Still, this acts as an AND. So it acts as an AND in what? In Python. So we call it an AND operator. It's called an AND operator. So you need to be able to use both of them. How about double of them? Let me just try to put 2 and run this. It will say it's an invalid. So it means it needs us to use one symbol, not 2. So this is a symbol for an AND. If you don't want to use this, so we can still use that to also say it's. But if we say it's A equals to 5, it's A equals to 5 and B bigger than, to say is true. How about we do the same, but this time around we use OR. So it means in terms of OR, it must satisfy one of the two conditions. It does not have to satisfy both. If it satisfies both, is still fine, but it must satisfy one. So let's say OR here. If I say OR, then it will say it's true because A is equals to 5 or B is it's bigger than 5. But how about if I say A equals to 3 or B, then it will still say it's true because remember it has to satisfy one of the condition, not all of them. For example, if I say less than 5, it will say it's what? It's false because it does not satisfy neither of the two. So you see that in terms of the OR operator, it does not have to satisfy both. As long as it can satisfy one of the conditions, then it will be true. It's very important. But how about if we change this symbol and we use this one? I want us to check something here. Let's use this symbol here and try to check. Try to run this. It will still say false. So it means this symbol is a symbol that can be used if we don't want to use OR. So this is the symbol for OR again. It's also called a bitwise OR. It's called a bitwise OR. So it means this can also be used. Like if you do not want to use this symbol, you're going to use a vertical line. This is the same as, it's called a bitwise OR. So it's one of the same things. So you need to be able to understand this. So these are called the logical operators. These are actually used to actually tell us whether a statement is true or it's false. This has to do with the Boolean. So it's very important in Python to be able to use these operators. These are very, 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 very important. They are very important. These are very important. You need to be able to know how to do this. For example, let's say if we say okay, no, but it's okay. Let's just proceed. Then I will talk about others later. We went through the arithmetic operation. We went through the comparison operation. We went through the assignment operation. We went through the logical operation. Let's now talk about the conditional statements. Right, we know in most of the case you find that you have to come up with statements that are conditioned on certain actions. Then when we are using the conditional statements, I think for now I'll talk about the if and else statements. Then in part 3 we'll talk about the while loop and the for loop and the others. All right, under the issue of the if statement, we actually used if statement. This has to do with the following in terms of its syntax. It says you write an if, and after this in the brackets there should be a condition. So we write a condition, and under condition, after condition, we must put the semicolons. We must put the semicolons, and after that there must be an action. There must be an action. But usually in the if statement, we use if with the condition. After if, then comes what you call the else. Then also with the action. Maybe we call this action 2 or action 1. For example, if I say to you, I say, okay, it's just an example. Now I want to incorporate what we have done yesterday with the issue of the inputs function. Let's say I want a learner to enter the mark. Say, okay, as an integer. Okay, we can also say as a float, but it's fine. Let's just say as an integer, and I want a learner to input the marks. I want a learner to input her marks obtained in mathematics. So I'll just say enter your maths mark. Then now, after entering, then I can use an if statement to say if, remember there should be a condition. If, but there's no need to put in the brackets, but you can also just put in the brackets. If a mark is greater or equals to 30, if a mark is greater or equals to 50, if a mark it's greater or equals to 50, then there should be a semicolon. Then we need to print this. We need to print to say you have passed. You passed the exam. So this is just an example of an if statement. So first of all, we're gonna say, okay, fine. Then we have to say to enter the mark. Let's say Elena got 40. Then you see it will just not show anything because there was no condition to tell if Elena who got less than 50, obviously did not pass. But now there's no any function which was stated there. It means if Elena enters the mark that is less than 5, then you just print nothing. Now, let's now do the running again. Let's say 51. Then you see it will say you passed. So it's telling the learner that you passed the exam. So which means under the if statement, we must also have other condition to say, okay, fine. We know that if a learner's mark is greater than 50 or equal to 50, a learner has passed. But you must also tell also when a learner has failed. So it means you have to come with something called the else statement. Else says, okay, fine. If the mark is greater or equals to 50, the learner has passed. Then already, instead of the else statement, even if we do not put the condition, but we just say print you failed, then try next time. See, it means this is the final statement from the if statement. So now let's say the mark is 40. Obviously, it will say you failed, try next time. So this is called the if-else statement. And again, in terms of this if-else statement, we can still have multiple if-else statement rather than just having this. So it means under multiple, then we're going to have to add another column to say, okay, fine. If we still have multiple columns, now we must come with something called the elif. So it's if, right? Then else if. So this is to do with else if the mark, when the mark is between what and what, then the learner did not pass or something like that. This has to do with the elif statement. I think I'll do another example. Okay, fine. Let's just say, okay, it's just an example. Let's say we have the following information. Okay, let me do one example. Okay, let's say in terms of, okay, let me just give one example here. Okay, I want to give one example. Okay, let's say as an example, we have like the marks are actually in terms of levels. So for example, a learner who got the marks between, let's say, between 0 to 29, this is actually level 1, then 30 to 39, level 2, 40 to 49, level 3, 50 to 59, level 4, 60 to 69, 5, 70 to 79, 6, then 80 to 100, that is 7. So let's say we wanted to tell a learner, okay, let's say we wanted to tell a learner, like to inform the learner in terms of whether the learner passed or not. Obvious, like if you want to tell the learner in terms of the level, the learner achieved, then we have to come up with something called the if-else statement. So to say, okay, for example, if we say, if I wanted to use the if-else statement, then I would say, if marks are between 0 and 29, then this learner got level 1. So to do that means I will say, if the mark is greater than 0, remember this time around, we want to include, so we want to use what you call the logical operators. Why logical? It means I wanted to say, as long as it gives numbers that are from 0 to 9, not all. I don't want to use all. I want to just to say 0 to 29. As long as the values are between, is bigger than 0, but less or equals to 29, then it means this learner got level 1. So it means I must use and. So I can either say, if the mark is, it's just an example here. If the mark is greater than 0, and also the mark it's less than or equals to 29, what must I print? I must just say, tell the learner that you got level 1, and a learner would not get level 1, it means did not pass. So did pass, right? Then now, what if I wanted to include the numbers that are between 30 and 39? So it means this time around, we're not gonna use the word else. So it means we must use what you call the elif. The elif, it means we are still adding other condition to say, if the mark is greater or equals to 30, greater or equals to 30, let me just say greater or equals to 30, and okay, actually I should put this in and. So let's do this. I think it also work in this fashion. Greater or equals to 30, and the mark less than or equals to 39 inclusive. Then now semicolon, print, you got 2 and passed. Okay, then now again I will do the elif statement again, which means we'll use the else statement at the last, just here. Okay, fine. If the learner got a mark between 40 to 49 inclusive, then the learner got level 3 and also passed. Learner passed. Then now, again, another statement, the marks that are between 50 inclusive and 59, the learner got level 4, still the learner passed. Then he just passed. Okay, let's just say good. You just say fair. Okay. Just here we'll just say very good. Very good. Then now within 60 to 69, 60 to 69, you see how we're using the logical operators. Then this learner got level 5, so which is actually let's just say excellent. Excellent. Okay, then now, okay, let's copy again. Let's do the copying. Okay, then now we do the same. This will be between 70 and 79. Then this got level 6, and which is actually same as Bravo, but it's okay. Let's just say Bravo. Keep it up. Okay, then now, then the last one, since the last one, then we're gonna say else. It means here there's no need to put the condition. You just say else print, because it has satisfied all other conditions. It means the last one it will know that there's no, if it's between 100 and then the learner you got level 7, which is outstanding. This is outstanding actually. So let's do the running. So already here it says, oh, it means the elif. I've included double semicolons here. Okay, let me get rid of this. So it's giving me a syntax error. Okay. Right, then let's do the printing. It says print, you got, oh, okay, fine. Understand what is append. Expected and a block after else. What is this? Elif. What is the problem now? Okay. Okay, just a minute, guys. Okay, line 15. Okay. You got level 7, it's outstanding. Okay. Oh, okay, understand. Right, now, let's say Elena got 40. Then you see, it will say you got level 3, good. Because the marks are between 40 and 43. So you see that here we use the logical operation. But how about if, let's say, we re-enter this again, and now this time around, Elena got, I think here, it's, okay, guys, I apologize. I just had connection issues. Right, I think here we need to also include something, because if, for example, if Elena put the marks that are above 100, then what's going to happen here? Let's say 105. You should just say the learner got level 7. Why? Because remember, we just said if any number that is not in the, so it means I think here we need to also give the condition to avoid that. So let's say then then let's say between 80 to 100. So it will say, actually, let's just say at least. Then now I wanted to give other condition to say, let's say else and, that's an valid. Please enter. Okay, just say, let me just use an F string. I want to check something. That's an invalid. At the same time, I want it to re-enter this mark. Okay. Let me put the mark here. Okay, apologies, guys. Okay. Okay, let me check what has happened here. Okay, let's do the running and check. It says okay. What has happened here? Okay, let me check. Okay. There is an invalid mark. Let it to re-enter. Okay, just put it there. It says the elif. Okay. The indentation. Okay. Right, let's do the running, ladies and gentlemen. Okay, it says after else. Right, let's say we enter mark on 80. You got level 7. Let's do the running again. Let's say we enter 10. You got level 1, did not pass. Okay? Then let's say we re-enter again, then we enter, let's say 102. It will say that is an invalid mark. But what was supposed to say, please enter. Okay, let me do let me, please enter the right mark. 105. Enter the correct mark. You see, it will keep on saying enter the correct mark because I'm entering an incorrect mark that is above 100. So if I say 120, it will still do the same thing. But now it has, it will just say that is an invalid. So let's do the re-entering again, 120. It says enter the correct mark. So when I'm entering the, let's say I say 8, then we just say that is an invalid. Oh, okay, I understand it's responding from the previous one. So, okay, fine. So it means now, if I do this, let's say, okay, let's do the running again. 70. You got level 6. Bravo, keep it up. So let's do the rerunning again. Let's say 92. Obviously, when I put 92, then it will say you got level 7, you've passed. So this has to do with the issue of if and else statement. Together here, I use the logical operation. The reason I wanted to end is that I wanted the condition to satisfy like everything there. And remember, we can still use this symbol. If you don't want to use this, you can still use this for and again. So it means we can still use this for and. We can use them interchangeably. They still give us the same result, 92. On 92, what does it say? It says you got level 1. Oh, okay. Now I understand. Okay. Now I understand. By the way, this is invalid. Oh, by the way, this one it's a bitwise. Oh, okay, fine. So let's just use and or another way. Let me do this one to check something. Let me put this in brackets. Check something. 92. Says you got level 3. Oh, it's here. It means if I'm using this, I have to use brackets, this bracket of this form. Okay, now I see. Let's do the running. Let's run this again. 92. Yes. So it means if we're using the end, it means all the conditions should be in brackets. This should be in brackets, and that should also be in bracket if you're using this condition. But if you're just using and, then there's no need. You can just put them in one one bracket. If you're using the and, it will give the same output. 40 and okay, then now we do the same. Okay, let's do the running. 92. Let's say you got level 7. So this has to do with the if and else statements. I believe you guys are following. These are if and else statements. Then in the next video, we'll address the issue of the functions. I believe you are following, guys. Yes. Then now we can move on to the issue of functions. Okay, then now, the other one is the issue of functions. Let's talk about function. Now we're going to talk about functions. Right. Functions actually works where we actually, let's say if we want to calculate something, maybe rather than doing it time and again, we just create a function. All right. Python actually uses something called def. Actually, this has to do with defining a function. So in terms of the syntax, we use the definition and we write the name of the function. Let me just say, this is an example, function name. After function name, inside there, we put the parameters that are needed here together with the semicolon. Then inside here, then we write the function that we are looking for. Then at the end, we must say return. It depends with what we want to return, a value whatsoever. So this is just a syntax that we want to do when we are different. For example, I think I've done an example where we said, imagine you are asked to calculate the area. I think I've done an example, or we can just say the volume. Yeah, let me just say the volume. Let's say volume of a cylinder. Is it a cylinder? Yeah, I think it's cylinder, which is pi r squared h. So this is the volume of a cylinder. You see that this volume of a cylinder depends on what? Depends on the radius, and also the height of that cylinder. So this is an example of a cylinder. So it depends with the radius and the height. So imagine we wanted to calculate the volume of this. So obvious to calculate the volume rather than doing it manually. For example, let's say we do it manually to say V equals to pi, let's just say pi multiplied by, okay, we can either use the pi to be like, we can import something called Numpy, but for now, let's just leave pi as 3,14. Or should we just leave it as pi here? We want to check something. Pi times this multiplication, the radius, let's just say the radius. Okay, let's just say here the radius is 40. So it means you're gonna put the radius, but this radius it's raised to the power, so it means we must use exponential notation to the power of 2, then come down, we multiply this by the height. So let's just say we multiply this by the height. Let's just assume the height is 20 centimeters, just an example. So now we want to calculate the volume of this. So you see, it says pi not defined. Let's just say pi is 3.14. Then now we want to calculate what is the volume of this. So let's just say print volume V. So it means this will be that value. Imagine if we keep on doing this, so it means we'll have to change the R and do this. So to avoid doing this, then we come up with what we call definition of a function. Then we say, okay, fine. We're defining a function called volume. And this function is a function of pi. But the red pi, we can just say pi, we know is 3.14. And it's also the function of the radius. It means we must input the radius, and it's also the function of the height. And then we put semicolon, then we start to say, okay, fine. What do we want here? We want a value of this. So it will be pi times the radius power of 2. Can I put this inside brackets? Then again, outside is just multiplied by the height. And I want this to actually return the value. So let's just do this. So it says non-default argument. Okay, what did I do here? Define volume radius. Radius is there, then the pi is there. So what is the problem? Okay, let's check something here. Okay, let's check something. It says, what could be the problem? Non-default argument. What is the thinking here? What did I do? Okay, fine. Let me change, or maybe I did not use, but there's nothing wrong there. Okay, means you must use radius pi, radius the height, and the pi, let's say pi is 3,14. Return value, okay. And to indent that. Right, you see now it's working. So what if I wanted to calculate the value now? Then it means I will say value equals to, now I call the volume, inside the volume, the radius is 40. The height is 20. There's no need to put the pi because already we said it's constant. Then print the value. It's still giving us the same answer. So it means in this case, we can still change this radius is 50 now. Then the height is still the same. The answer will now change. So this is the formula for calculating the height is the formula for calculating the volume. So this is just a function that actually in most of the cases we use functions to make to make calculation rather than keeping on changing the equation. This is how we use the function package in Python. So it's very important. We just use the word def. We state the name of the function, then we put in the parameters that we wanted to use, then we create the equation, then we come up with a return value. So this is the function that we use in Python. That is the function we use in Python. For example, let's say, as an example, let's say I want to calculate we want to use the quadratic equation. So let's say we want to calculate the value of x. So obviously we're going to say x, it's minus b plus or minus the b squared minus 4ac over 2a. Obviously, if you wanted to define a function, so okay, fine. You define quadratic equation. Under quadratic, we want to get the a, the b, and the c. That is what is needed. And we're going to say, let's call this x1. This one will be in brackets minus b plus then the square root. So this time around, I need to import Numpy, but we'll talk about this. Numpy as NP. Then now this will be NP dot square root. So I wanted to use the square root. Square root of b squared. So I want to use square root of b squared. So b to the power, double the powers here. Use the b to the power of 2 minus 4 times a times c, close brackets, and again close brackets, divide by 2 times a, divide by 2 times a. Then this is the first value. Then the second value would be minus b minus, copy the same thing now. So this will be the same thing, minus b minus np squared b squared. And then in the brackets, divide by 2 times a. Then now I will say it has to return. Okay, it has to return. Okay, let's just say I wanted it to display as a list. So let me just say create a list. Just say values. Values is, I'm just making an empty list. Let's just call this roots. So I'm now incorporating what we have done yesterday. So okay, fine. Then this is just an empty list. So I've created an empty list. So within this, we wanted to calculate the value of x and y. Then the value of x, the values of x actually. Then now I have to say values. What can I do? I will say, okay, values and okay, let me just say, values dot append x1 After that, then we say values dot append. I want to use the append x2, or I'm not supposed to say values because the list that I've created there is called roots. So roots and roots, and then from there I want it to return that list. I wanted the function to return the roots list. So let me run this. Already, let's say we have the following. It's just an example. We have the following, and we want to solve algebraically. So let's say we have the following. We have x squared minus 2x minus 10. Okay, let's say minus 5 and 2. Okay, let's say minus 3x minus 10 equals to 0. If we were to factorize this, this will be x and x, 5 and 2 minus and plus. So which means x should be 5 or x equals to minus 5 or minus 2. Okay, from here we know it is in the form of ax squared plus bx plus c. The a we have, the b we have, and the c we have. So let's do this. So it means now we're gonna say values. It will be quadratic. I'm calling that function quadratic. Under quadratic, we want to know what is the a. The a is 1. What is the b? The b is minus 3. And what's the c? The c is minus 10. So let's say we want to print values. Want to check something here. If we do this, it will say that the values is 5 and negative 2. Okay, let's say whatever we are doing, let's say we want to round these to 1 decimal places without, like, we want to let this number to be, okay, let's say I wanted to append an integer of x1. I'm appending an integer of x1, x2, integer, just an integer. Let's run this. You see, it says it's 5 and negative 2. So we got x equals to 5 or x equals to negative 2. So you can easily see that we can calculate this is another way we can use using the list and just the functions. So it's another example. We can even change, let's say we change and say, as another example, let's say we have the following. Let's just use the other one, which will give us decimal. Let's say 3x squared minus 4x. 16 4 times. Okay, let's say minus 10. Obvious, if we're to do this, means I might need the value to be not to be rounded. So let's do away with the integer. Okay, let's do away with the integer. Let's put x2 here. Let's run this. Then here it means the a's will change. The b, it's negative 4. The c is the same. Then now let's do the running. You see, it says 23.49 something. What if we wanted to round this to okay, I'll say round the value in how many decimal? Let's say 2 decimal. Let me just put 2 decimal places. Then also round the value into 2 decimal places. Let's do the running and check. You see, it's now rounding the value to 2 decimal places. So this is how we use functions. Functions are very important when you are dealing with Python. All right. Then the last one is the issue of using what you call a range function. Right. Let me talk about this thing, range function. If I say range is just an example, 6, and say run. You see what is doing is just showing the range of numbers from 0 to 6. Just not necessarily showing numbers, but just printing the whole result. But if I say, for example, if I say 0.6, then let's say 0.6 is just an example. Let's say run. It will still do the same. But if I say 0.6 with the 1, it will still do the same. But if I say I use the word A range, if I use the A there, look what is going to happen. Okay, say it is not defined. Okay, so let's np dot range. So it says numpy is not the function called range. So, but if I say a range, look what it's doing. It's actually displaying numbers from 0 up until 5. So it's 0, 1, 2, up until 5 with an increment of 1. So it means I wanted to talk about the way the function a range works. So it means inside the function range, it has what is called the start of the value. Here it has what you call the end, and here it's what you call the step. For example, here if you can see, it means it has ranged value from 0 up until 5, but not including 6. So, but with an increment of 1. So let me just explain this. It means it increases values from 0 to 6, but not including 6 minus 1, but this is a step size with an increment of 1. So it means if I change this and say the range from the A range from 0 to 6 with 2, well, you know what it will do? It will just say 0, 2, 4. Look at this. Actually, let's just change it. You'll see how it works. If I put 2 here and do the running, you see it says 0, 2, 4. So it means it increases this 2 here, it's actually the step size. It will increase the values by how much? By 2, but to up until the 6 minus 2, which is actually 4. It will not reach at 6. For example, if I add this, let's say I add 8 here. Look what it will do. It will only display from 0, increases by 2 up until 8 minus 2, which is just 6. But if I put 3 here, look what it will do. It will increase numbers by 3 up until stopping at what? At 6. So it's very important to be able to use what you call the range function. The range function is very important. Let's say I wanted to range to show the numbers that are from 0 to 9. Obviously, if I want to show the numbers that are from 0 to 9 with an increment of np.arange with an increment of 1, then I'll say 0 to 10. Even if I don't put 1, it knows that will increment that from 0 to 9. So it means we have numbers from 0 to 9. But if I put 11, it will be numbers from 0 to 10. So, but if I put 12, it will be numbers from 0 to 11. So that is how the A range works. And this is very important, especially when you are dealing with something called the for loop. So, ladies and gentlemen, I think I'm done with session 2 of this video. I believe you will enjoy it. Thank you very much for listening. Bye-bye.